Welcome to the ASES October webinar. I'm Lauren Reddington, National Solar Tour Director and Webinar Manager for the American Solar Energy Society. And I would like to thank you all for joining us on our monthly webinar series. To kick off, I would like to inform you of who ASES is and highlight some of our current events and programs. The American Solar Energy Society is a 501c3 nonprofit organization that was established in 1954 and advocates for sustainable living and 100% renewable energy by sharing information, events, and resources to cultivate community and power progress. You can join our community at any time at ases.org/join, and webinar registrants get a special 10% off discount on all ASES memberships, including life memberships, by using promo code webinar. Save the date. ASES will be having our 52nd annual National Solar Conference, Solar 2023, Transforming the Energy Landscape for All in Boulder, Colorado at the University of Colorado Boulder from August 8th to 11th, 2023. The National Solar Tour is a truly effective program for increasing solar adoption and the implementation of sustainable upgrades by featuring a collection of local solar tours, in addition to single solar sites across the country that feature solar and sustainable technologies. This year's National Solar Tour was a success with solar and sustainability events in all 50 states. The in-person tours have now passed, but you can check out all the virtual tours at nationalsolartour.org/map until January 15th, 2023. ASES also invites you to participate in our online community. This is a space for our community to collaborate, share content and information, and network with each other. We have a special Ask a Renewable Energy Expert Forum where we have our technical divisions experts on call to help answer your questions about anything solar or sustainability related. Be sure to hop online and start engaging at community.ases.org. Thank you for listening to these ASES updates. I want to note that this webinar will be available in a recorded format soon. I will follow up with everyone once it is available. I will ask that you submit your comments to the chat section and questions to the Q&A section. We will review and answer everything at the end of the presentation. Now I would like to introduce you to today's presenter, Tim Eian, architectural engineer, certified passive house consultant and designer. You could say Tim was destined to have a career in architecture. At age 3, he followed construction progress of his new family home in Germany with fascination. As a young teenager, he worked as an intern with his parents' architect. Already realizing his life passion, he further prepared himself by mastering the foundations of woodworking in a carpentry apprenticeship, earning the title Master Carpenter. He later graduated with honors, earning an architectural engineering degree from the Technical University of Germany. Tim has over 25 years of experience in both Germany and the US, deeply influenced by exposure to stringent German environmental policies throughout his formative years. He has a strong conviction that protecting the earth for humankind is one of the key challenges of his generation. With the desire to take residential design to a new level of sustainability, Tim founded TE Studio in 2008. The same year, he started designing the first certified passive house in Wisconsin, which is also the first to offer plus energy levels of performance in the country. Tim was a founding board member of the Passive House Alliance, US. In 2008, he also founded Passive House Minnesota, now a chapter of the Passive House Network. Tim and his firm have been instrumental in educating and transforming how Minnesota owners, developers, municipalities, and building professionals think about high-performance buildings. He and his family live in Minneapolis, first certified Passive House Plus. I'll now turn it over to Tim.
Thank you so much, Laura. That's very kind. I will share my screen and we'll get going. Just going to confirm here real quick that you can see that.
Yes.
Great, wonderful. Well, thanks again for having me. I want to introduce you today a little bit to the Passive House Building Energy Standard. It's going to be a little bit of a fire hose. I'm going to try to tell you what the Passive House Standard is, why it is valuable for what we're trying to achieve here in the United States, and then also give you a case study example of a Midwestern cold climate passive house project from beginning to end. So often the first question is, why are we even talking about this? Aren't all buildings green? Well, in reality, buildings are very important to us, but they're often failing us. We spend a lot of time indoors, and buildings account for 40%, some say even more, of global emissions. And they're often unreliable, expensive, and they can make people sick. So these are the reasons why we're still talking about green building. So if we for a moment then imagine the perfect building, for school, a home, a workplace, entertainment, how would most people describe it? And, we're in a cold climate here. So what I hear most commonly is, people want it warm in the winter. They want it cool in the summer. They don't want drafts. They want low energy bills and little to no fossil fuel use. They want it to be affordable to build and operate. So we're looking at life cycle costs, perhaps. Buildings should be healthy and free from smoke, soot, pollen, mold, and bugs. And they should shelter us even in extreme weather events or during power outages. For those living in busy environments, they should be quiet, and they should be a little bit of a retreat, place where you can think. And the good news is that all of this is real. In 1991, a guy named Wolfgang Weiss built the first passive house in the world in Darmstadt, Germany. And that's what I'm going to talk about today, how passive house delivers on all those fronts. So let's start with the textbook definition. What is that even? Well, first of all, it's a rigorous voluntary building energy standard focusing on the highest energy efficiency and quality of life at low operating cost. So you can already get a sense that we're answering some of what people want with this program. It is a global standard. So the concept behind it is to think globally but build locally, and it is climate zone specific. So these buildings will adapt and look slightly different depending on where you are on the planet. It's also a building standard that applies to all building types. I'll give you just a few highlights, recent highlights, I would say. The city of Frankfurt built a new general hospital that is fully passive house certified. That was just completed earlier this year. In New York City, there's a full block development underway with hundreds of living units and some mixed use units. That is a passive house project. In Vancouver, they're working on the tallest passive house skyscraper in the world right now called The Curve. Here's a school that was built in Germany some years ago. The Carrick Library in Pittsburgh, Pennsylvania, 4 or 5 years old now, passive house certified. A museum in China built to the passive house standard. And a Subaru dealership of all things in Alberta, Canada, also passive house certified. It's a third-party certification, and it's really a vetted tool for sustainable design. So it exists on a global scale, and it's been vetted by organizations like ASHRAE, for example, for accuracy and how it's applicable in our environment. It offers multiple tracks, as some other standards do as well. There's sort of a classic, plus, and premium. There's also a retrofit component. And it really revolves around one basic concept, and that is energy conservation first. Let's get rid of wasteful energy use, so minimize our losses and maximize our free gains. And there are generally 5 principles that this is footed on. I'll start at the lower left-hand corner there, thermal insulation. So we insulate buildings appropriately to the climate zone that they're in. This is not a given with American codes, unfortunately. Then we offer up what we call passive house windows in a cold climate, more often than not triple pane, well-gasketed windows with a high solar heat gain component. We bring in an adequate ventilation strategy, typically with a heat recovery ventilation system. We air seal the building really tightly so that we don't have any drafts coming in or any heat loss going out. And then last but not least, by design, we reduce what's called thermal bridges, which are generally like superhighways for energy to escape a building through envelope imperfections. Passive house gets its name from the paradigm shift. We're literally moving from buildings that rely on large active heating, cooling, or ventilation systems to something that's much more self-sufficient and is based on passive strategies such as insulation, air sealing, as I said, energy retention, and then getting warmed by passive means like passive solar heat gains, for instance. And so generally you can expect a reduction in heating energy need by about 90% over quote normal buildings when you go down the passive house path. So it's really a paradigm shift. And if you take the tent here that I put up in just a little bit on the left as sort of the current paradigm of a not so great building envelope with a big heating plant, we're bringing again the super insulation, the air sealing, here signified by the cooler box and the vacuum bottle. And once you do that, you can heat the whole thing literally on a candle. A study that we conducted in Minnesota showed that if you take the same home and you design it to Minnesota code and then you design it to passive house, you can expect, as I mentioned, up to 90, sometimes up to 95% less heating energy use and 50 to 75% less total energy use. Also, the way that energy gets used changes entirely, with heating no longer being the major consumer of energy. Passive house gets quantified in certain metrics. We won't have time to do a deep dive here today, but there is a heating and cooling energy target. There are source energy targets. There's a suggested heat load target, and there are energy targets. And when you're doing a retrofit, there are also component targets, because sometimes it's not possible to elevate an entire building to a certain level of performance, but you can still upgrade individual components to a certain minimum level of performance. And all of this is typically modeled in design with a tool called the PHPP, the Passive House Planning Package. So this is something that's unique about passive house. It is not just an aspirational standard. It sets real hard absolute targets and provides the team, the design team and the executing team with energy modeling tools to track their progress all throughout. I'm going to skip over some of these slides here because, again, we can't do quite the full deep dive. But one other thing that I would like to highlight is that in passive house, we shift where you invest in a building. If you look at this graph here for a hot second, you can see that each component within a building has a different life cycle. Obviously finishes get exchanged much more frequently than the structure of a building. And so if we take this grid as 100 years, you can see that we have many finish upgrades throughout the life cycle of these 100 years. But with passive house, what we're doing is we're really shifting an investment away from the HVAC component and embedding it in the building envelope in things like insulation, better windows and doors. And they also tend to have a longer life cycle. So any dollar that you invest in the shell of a building is generally a longer dollar than a dollar invested in HVAC componentry. So in short, passive house defines the long-term building quality and performance independent of energy supply. We'll talk a little bit about that today as well. And it reduces the amount of useful energy needed to operate the building significantly. So with that, I'll dive into a quick case study of a building that my company here designed. It's actually the house that I'm in today. It's called the Good Energy House, 2,000 square foot single family home in Minneapolis, Minnesota. We built this here a few years back in partnership with some companies and vendors, which I have to thank at this opportunity for making this possible. And we're also big proponents of sharing the knowledge, as I am with you today. So we're members of the Passive House Network, and this project here locally was accompanied prior to COVID, obviously, with a lot of open houses and educational events. We also work with the city of Minneapolis to demonstrate how we can do carbon neutrality in the urban core. And so that's another takeaway from this project. So we're located in Minneapolis, not quite in the heart of the city, a little bit on the outskirts. And this is a typical situation of a tear down rebuild, which happens in the urban core frequently here where I live. So there was a house that was in quite of a bad state and needed to be demolished. Just a couple of impressions here. To make room for this new construction. One of the benefits that we had with this property was that it faces due south, one of the things that works well for any passive solar design, such as a passive house. So one of the key things that changed, from the existing layout, often of an entire neighborhood to this passive house, is that we ended up rotating essentially the design. So where the existing home stood east-west facing, the new home stands north-south facing. And the new garage is actually on the north side, so it acts sort of as a buffer or shelter for the building. You can see that here on that first floor, where the bar on top is the garage. Everything is oriented properly, north is up. Just a couple of impressions here. You can see there's lots of glass. So one of the urban legends often is that you can't have glass in a high performance building. Not true, you just have to use a really good window. And these windows are actually the passive solar heat gain collectors, and they deliver about 60% of the heat load for this building over the course of the winter for free. There's a second floor on top. There's no basement here. There's 3 bedrooms, a couple of bathrooms, and a utility space on that second floor. And there's a little vertical space balcony. So a little bit of architectural nicety as well. So it doesn't just have to be an economy box. You can have quite a bit of architectural freedom when you're working with passive house. So what's under the hood? What makes this tick, or what makes it different? Well, first and foremost, the building envelope. That's really the focus of a passive house. And so just to give you some comparison here, everything is insulated from the foundation that the house rests on all the way up to the roof, obviously. And most of it quite significantly, compared to Minnesota code, you can anticipate about 2 to 3 times the level of insulation to get to passive house levels. And when you do that, you're really changing the game for how the building behaves. We're going to go from the ground up. I'll show you what some of this looks like. So excavation, similar to other buildings. One change here is we have to make this nice and level and smooth, because the whole building will be footed on insulation, as I mentioned. In our particular case, this is footed entirely on foam. There are efforts to also get away from foams in construction. That has other benefits. But when it comes to load bearing, the foam at the moment is still the best way to go about it. So this is literally the bottom of the foundation right here. You can see that is all laid out in foam, and the foam was actually used to make the formwork for the foundation itself. So later this is flooded with concrete. There's rebar, reinforcement bar in there to strengthen it. You can kind of see that coming in right here. And there it is. There's a fully insulated footer. So no part of this building touches the environment thermally, so to speak, and thereby is completely disconnected. The foundation walls are built from insulated concrete forms. You can see them being delivered there and then erected right here. For those of you who have never seen these are essentially forms that stack a little bit like Legos. They provide a cavity for reinforcement bar and a concrete fill, and therefore a solid foundation wall. You can actually build entire buildings from this material, and we have for passive house as well. But in this particular instance here, this house is just set on top of this as a foundation. In Minnesota, I know some of you may be in completely different parts of the United States. We have to foot our buildings about 3.5 feet in the ground. So that's why you're looking at this. The foundation has to be that deep. Northern parts of Minnesota, we have to go 5 feet deep. So there's no basement, even though this may look like it. This is literally just the foundation and then later backfilled. A couple more detailed shots here of how these ICFs work and then how they're core filled. So at this point, we're creating the load-bearing concrete center of it, if you want. And then more insulation comes into the picture. These ICFs are great. They offer a minimum amount of insulation out of the gates, and then more insulation is adhered to it to give us the R value, the insulation value that we seek. Everything is packaged in that insulation, and then a waterproofing material is installed to make sure that none of this takes on any moisture from below. And this would be the same if we had a basement. It's then backfilled. A radon system is installed, plumbing is installed, all the things that need to happen below a slab. Some impressions of that here as well. One of the things that we want to do is we want to lay this out, very in an organized fashion, I should say, because later we will have to air seal around each one of these pipes and make sure that we don't take on any radon or other moisture or soil gases. So from there, we move towards the construction of the frame of the building. This one here is a wood constructed building. The walls are 2x8s, spaced 24 inches on center, built in a methodology called advanced stick framing, which really minimizes the amount of wood that is used in favor of larger cavities to take on more insulation, because that's what we need for a well-functioning building envelope. The rest of it, fairly standard fare. There are floor trusses, I-joists, and then it's platform framed. So it basically works its way up from the bottom to the top. This building has a low slope roof, so there's not roof overhangs here. but that doesn't matter. That's a design choice. One of the things to highlight is that we utilize the building's sheathing, in this case, the Uber Zip product that you see here, to also make the air barrier. So this is the location at which the wall is air sealed, and that's why you can see that tape there for every joint. In standard construction, this material is sometimes used as the outer skin and the weather barrier, but for this passive house, it is really just the air barrier and the bracing. And that paradigm extended all the way up to the roof. So on top, there's a hard membrane as well that we sealed. Some detail shots here of that happening. And then the wood wall itself was also sealed to the foundation wall down below with more tapes. The wood wall is a double stud construction. So outside of the 2x8 frame, we used floor trusses, TJIs, 10 inches in this particular case, and ran them up vertically the entire face of the building for a secondary cavity. And they just happened to also make the parapet on the roof, which is something you need when you have a low slope roof. So you can see that whole ensemble coming together right here. We're going all the way around. You can see the window openings being bucked out. So there's basically a frame that goes around that to later hold the windows. The roof gets installed next. So this roof is a hybrid construction. The roof trusses are filled with insulation. There's more insulation with a taper on top of the roof. And from there, the water drains from the top of the house to the lower level, and from there into a couple of rain gardens, which in the year we built, we got to test many times. It was one of the wettest years on record, as opposed to the last 3 years, which have been really dry. So then once the box is installed, we go to the slab installation. As I said earlier, plumbing is already in there, radon system is in there. So you can see that all gets screeded out and laid flat. Sub-slab insulation comes in. Here in our Minnesota climate, we're using 8 inches, sometimes 10 inches of foam that just gets laid out. And then the next layer is really our soil gas barrier. We want to make sure that nothing leaks up or wicks into this whole system. And this is where I was talking about well laid out plumbing. We seal around it to make sure that we don't have any imperfections. Next step, reinforcement for the slab, and then the concrete pour to get the slab installed. So from there, we can move on to the window installation. I'm mixing in some finished product shots here so you can kind of see what that looks like. These particular windows are triple pane units, passive house certified windows. They were made in Europe, which today a lot of them still are. We don't really have much support here from local vendors just yet for passive house windows. So they ship in a container to site, and from there, construction workers grab them and install them in the building. Just a couple of impressions here of that happening. Obviously, the larger they get, the heavier they get. And so in some cases, there's equipment needed to move them around. So with the windows in, the building is essentially sealed up. We don't have any, any unwanted visitors in the building anymore. Now we can start looking at building it out and insulating it. So this particular building is insulated with blown cellulose, and that's a very basic system of a very low embodied energy material that just gets blown into these cavities. It gets blown into the roof, it gets blown into the walls, and it essentially makes a custom bat, if you wish. So at the end of it, it molds itself perfectly to those cavities. At the roof, we installed what we call a service cavity. So the ceilings are all suspended down and any mechanical systems are built inside of the shell. That's good because we don't have any protrusions, anything going in and out of that well-insulated air-sealed shell, and no weak spots of that shell. Just a couple more impressions here of the frame of the building. And here you can see why we try to reduce the amount of lumber in the wall just to really maximize the amount of insulation that we get out of the system. So part of the house was insulated from the interior, part of it was insulated from the exterior. There's just a quick shot of how that worked. Then once that shell is in this state, we do some rough and blower door testing, making sure while we still have access to the building that we can correct any leakage that might be happening here. This is commonly done with a blower door fan, maybe some tracer gas, as you can see here, or a spotter. In passive house, we have an air tightness limit of 0.6 air changes at 50 pascals for those of you who can associate that. Minnesota code, by the way, is 3.0. So a passive house will be 5 times tighter than code allows. And so this building here blew a 0.36, which is again almost twice as tight at the rough-in stage. With that complete and out of the way and checked off, we can focus on mechanical systems. And this is where we connect perhaps with a green grid and renewable energy systems, because one of the things that happens when you build a passive house is your loads are so low that it makes an ideal candidate for heat pump and electrification. So what you can see here is both a heating and cooling system on the right and a domestic hot water system on the left. Both of them are heat pump based systems. And that works even here in Minnesota, where we have a design temperature of -20 Fahrenheit. So we're actually able with a cold climate heat pump to still heat this passive house with an air-to-air heat pump through the winter. For ventilation, that was one of the main components of a passive house. We bring in a heat recovery ventilation system. So essentially the entire house gets ventilated 365 days a year, 24 hours a day. You can see in red the zones that get air squirted into them, and then in blue the zones where air is being picked up and thrown back outside. So in short, we bring air into the living spaces, offices, into hangout spaces, bedrooms, and we extract it from kitchen, bathroom, and laundry spaces, and thereby removing contaminants, odor, moisture from the house continuously. There's really no way to achieve this level of air quality with window ventilation. And all of this is filtered as well right in the machine. So here's a quick overview of how a system like that looks. That spaghetti that you're looking at right there is dedicated plumbing or piping, if you want, for those air streams to and from different parts of the home. You can see in the lower right-hand corner a little ceiling register or rough-in register. These pipes are only about 3 inches in diameter, so that's just about the width of your hand. And again, this runs all the time, and thereby they don't have to be large. It's also extremely quiet. Arguably, it's inaudible. The machine itself for a residence looks a little bit like a mini fridge in terms of its size, but what it is that box in the middle of the picture here. And basically you have a fan that pulls air in and a fan that expels air. And in the center of the machine would be a heat exchanger core where these air streams bypass each other without contaminating each other. So they just get to exchange heat and or moisture, but they don't get to transfer any of the contaminants. A deeper dive here on how something like that is controlled, not so important today, but in lieu of any exhaust devices in the house, such as a range hood or a dryer, we use this whole house system to continuously turn and evacuate, spaces that produce, like I said, moisture or odor. So case in point, in our kitchen, we have a recirculating range hood with a grease filter and a carbon filter for odors, but then from there, the air is picked up and brought outside through the whole house system. These vents are fairly unobtrusive. These discs are about 6-inch in diameter, and they're fully adjustable to dial in the system. So there's supplies and returns, and that's really all that is. The dryer, as I mentioned before, is a heat pump dryer without exhaust, so no imperfections of the building envelope. And again, in an airtight building, you couldn't suck on it and squirt something to the outside because there's no hole for that to be replenished anyway. So some of these things change in terms of what technology would put in a passive house. So we monitored all of this with an air quality monitoring system here and find that it is working to spec. And so we have generally very good and healthy indoor air quality, no matter what the contaminant load outside of the building or what we're doing inside. That system can be automated. It can be controlled by a timer. You have control over it with your fingertips. Most of these things are app-based these days. So again, without doing a deeper dive, you have a lot of control over the ventilation in the passive house today. One other thing I wanted to mention here is that the heat recovery in certified units is so good that in a Minnesota winter, on a Minnesota winter day with -70 Fahrenheit outside, without any additional heating in the box, we can still supply 60° Fahrenheit air to the home, which is quite sensational. The garage of this house also has some ventilation here. These are point source ventilators, and I've seen some people use that all throughout passive house buildings or in small apartments, for instance. So this is a similar idea, but instead of connecting it up with pipework, you're essentially using point sources. So there'd be pairs of these installed in a push-pull fashion, gets you a similar result. The heating and cooling system is in part very conventional in that it is a sheet metal duct system with a supply trunk and a return trunk, which is air sealed. The supply side is well insulated, and then the whole thing is connected up to a cold climate heat pump, as I had mentioned before. You can see that here. In our case, there's also heat in the garage. For the winter, we keep that frost free. Both of them connect to the same outdoor unit, and that is not a joke. That small little outdoor box that you see there is the whole thing that is needed for this 2,000 square foot home in a cold climate. As I mentioned, this is a 12,000 BTU unit. So literally at full bore, it is about the same energy as 2 hair dryers running at the same time that will keep this warm through a Minnesota winter. We played around with a dehumidifier because I occupied the home. I wanted to see what that does in all reality, at least in our climate zone. We don't really need that here, all but a few hours per year. Some passive house buildings need a humidifier in cold climates. I guess I'm leaving this here as a placeholder just to kind of touch on that subject. So that may be something that's wanted or needed depending on where you're building a passive house. When it comes to the plumbing, we want maximum efficiency. So all pipes are insulated inside of the building. Hot water, so we don't bleed off any heat from the hot water system into the house itself when we don't start heating the house with the hot water system, and cold water just to avoid any condensation. I'm also showing you here a wastewater heat recovery unit, which is a heat exchanger that's connected here. What that does is when you're taking showers and there's warm water going down the drain, the cold water from the city loops around it and is pre-warmed by a passive means. And that lessens the work that the hot water heater has to do by about 30%. And you pair that with a electric heat pump water heater, and my family of 4 here can essentially get by on less than 2 kilowatt hours of electricity per day for hot water, which is next to nothing. I'm going to go fast through some of these here because they're not particularly relevant to a passive house. Obviously, if you go to the length of making a building at this quality, you want a really good weather barrier. So I'm just leaving some of these pictures here to illustrate. We want a continuously wrapped building. We want to ideally do, if we have a siding like this building does, back ventilated siding package, which is good for building science in just about any climate zone around the planet. So I just want to show you that care was taken wrapping this building properly and doing a back ventilated siding package. This house also has exterior motorized shades. So above some of the windows, there were voids left to then later receive an exterior motorized shade, which is a little bit like a mini blind on steroids. I'll show you that as well. So that's what you were seeing there. As far as the build out of a passive house goes, you can do just about anything you would do in normal construction. We added a little bit of soundproofing. This picture shows, again, the suspended ceilings at the top and some of the ventilation equipment there in place. Same here. So again, you might want to be a little cautious with off-gassing products just because you are installing into an airtight building envelope, excuse me. And we want to make sure that we don't bring any additional contaminants. So in our case, we took great care of the material choices. Paints and things like that were all low or no VOC, just to make sure that there isn't an additional burden inside of that building envelope. And then just some fun opportunities, combining energy efficiency with modern technology right here. So we used a lot of LED strip lighting that is built right into the building. So it uses very little energy, gives you good light. It's just a fun and great companion for a low energy home like this. So again, a couple of impressions of the finished product, so you can sort of put 2 and 2 together of how that all works. And this is where some of those partnerships came into play. And again, thank you to the people who supported us in making it happen and making it a fantastic building. So on the material side, maybe one more thought here. There's a lot of talk these days about embodied energy in building materials, because carbon in buildings is not just operational energy, which is what I was just talking about, but it is also the energy it took to make components. And that has a lot to do with the quality of a component, but also the service life. And so on this project, we also wanted to demonstrate that. So working with wood is great because that's a product that basically stores carbon. So we have real wood siding on the project, and if you back ventilate it, again, this is something that can really go the distance and last, there's precedent in extreme climate zones for wood structures lasting hundreds of years. So that's something that you can look at. And then the other part that we did here is we used the steel siding. Minnesota has a pretty aggressive climate. And so using a material like metal, that is very, very durable and has a high recycled content, can be a great alternative. Again, properly installed over these furring strips, so it's back ventilated. This will also go the distance and needs very little to no maintenance. So it falls right in line with the idea of making a building that offers low life cycle cost. So here you can start to see the whole thing as it comes together. And you can also see the shades starting to pop up in some of these pictures. So you can see that sometimes they're down, sometimes they're up. So I'll talk a little bit more about that. With the passive house being a passive solar design, our south-facing windows are essentially passive solar collector. And power is nothing without control. So now we need a thermostat for these windows if you want. And we partnered with a company called Loxone that provides a automated system that can control these exterior motorized shades to help us get on top of these heat gains and manage when they come and how much of it we get. So there's a combination of a little server that I showed you here in this picture, and then a weather station on the roof, and that combines with some sensors in the rooms that have these shades. You can see the products themselves here. So the shades are upper left-hand picture there when they're sort of coming out of the packaging. We have what's called a shading actuator, which is a little device that is controlled by the backbone and telling the shade when to go up and down and what to do. The shade box on the building, which is where the shade itself is installed, and then a controller that is app-based. So you take all that in sum, and these things can essentially navigate for themselves based on some parameters that we set for them. So this comes into play in a number of different scenarios. Most people think about shading in terms of summer, but actually in the summer, especially on the south side here in the Midwest, the sun is so high in the sky that the windows practically shade themselves. So really, this is much more of a swing season measure, and then also a measure for the east and west facades, just because on the east and west side of a building is where we see very low sun angles, which penetrate, where the sun penetrates the space deep. And so there might be times of the year when that's simply not wanted. I mean, beyond all of that, and I just gave a whole lecture just on shades that you might be able to find online through the Passive House Network, but other benefits, of course, are glare control, daylight control, and privacy, and these things will do all of that. So they are multi-purpose if you want, but this gives you an impression here of the dance that they do over the course of the day. And in reality, they don't all go down simultaneously like you see in this picture, but it's going to be more specialized than that, where they know which space to shade. And so based on the sun's angle, you'll see this sort of move around the building over the course of the day. All right, so at this point, the building is all but done. Final blower doors test is conducted, and this building blew a 0.22 ACH 50, so it got a little tighter yet again. So it's just about over 10 times tighter than Minnesota code stipulates, and that's good, so there's no leakage here. Now to the part that caters to our umbrella organization for this event here today. We also installed a solar PV system together with some monitoring on the roof. You can see it here in all of its glory. So the roof was filled up with 38 panels, about a 12 kW ballasted system up there. Was installed in the winter, doesn't matter. In Minnesota, we do work year round on projects. And so this 12 kW system provides us in its second year now with a full offset of everything that happens in the building below. We can squeeze some of our driving into that umbrella as well, but depending on how significant of a winter we've had, sometimes it fits, sometimes it doesn't. So in the first year, I think we were left with about 2,000 kilowatt hours from driving that didn't fit in the umbrella. This year, it looks like it may be somewhat similar. It's hard to know how cold and quickly how cold it'll get here in Minnesota before the end of the year. But what I'm suggesting here is that with its own roof, a passive house property, even in a severe climate zone like Minnesota, can become net zero over the course of the year, which is really a tall order. And again, this is all electric. There is no gas, no cop out. There is no gas burn, no oil burn, no fireplace or anything else that is making up for the bulk of the difference here or anything like that. It's just energy retention with a passive house means. All right, so there's another impression of the panels on the roof. We monitor everything with an e-gauge system. I won't have time to get into that today, but again, if somebody wants to look at numbers, they can always contact me and I can tell you what we're seeing here. So let's do a quick dive on the benefits of passive house in regards to green grid, renewable energy. You know, what does this all do for us? Why do we build passive house buildings? Well, so the climate is changing. Why don't we? You probably heard this before. And a few years back, I gave this lecture, an entire lecture on this called The American Dream Redefined. We really have to change the way that we go about business to fit into the world that we live in and make sure that we don't go extinct. So that's me and my family a few years ago, at a climate strike event here in Minnesota. The American dream of the 20th century sent us down a path that is tough, is not really compatible with the reality around us. In 2013, the average American sat on a carbon footprint of 20 tons per year, when 1 ton is thought to be about sustainable. So it's kind of turning into the American nightmare of the 21st century there. So that equates to about 12,000 watts per person of continuous energy above our heads. So think of that as light bulbs burning over your head, right? And back then, only 1,250 of those watts came from renewable resources and the rest from non-renewable. This will look a little better today, but not significantly, especially if you're living in Minnesota. So the target, that 1 ton a year equates to about 2,000 watts. So and off the 2,000, only 500 can come from non-renewable resources. Well, how do we do that? Well, we have to ladder up to a different paradigm here. We have to look at this sufficiency plus efficiency paradigm versus just making clean energy. Why? Because the clean energy plan alone is going to make us very vulnerable. It's not very resilient. It will cost us an absolute fortune. So what you're looking at here is just how do we get on top of those remaining 8,000 watts. And what I'm suggesting, especially for the built environment, is that we do that with passive house. We simply do away with wasteful energy use, we reduce it altogether. And if we do that successfully, we darn near have enough renewables on the grid to run the show already. So that means we don't have to build so much clean energy, which will save that money, make us more resilient. So with that, I offer up that passive house is foundational, not aspirational, as it is sometimes portrayed in the media. And in the passive house realm, we coined this phrase of efficiency being the first renewable energy. And I hope that resonates with you here today. Just a couple of things to bring it back home. It is a third-party certified standard. So just keep that in mind. People can get certified, products can get certified, buildings can get certified. There's some value in doing that. I always want to plant the seed for that as you're taking this into your community or thinking about passive house. Please also consider certification. It's one thing to say I'm doing something. It's another to get a third party involved to testify to the fact that you actually did. So with that, just a couple of impressions here of the finished product. So again, this can look many ways. We can do architectural designs. We can build more conventionally. You saw some examples of different building types. So again, it's not just a residential standard, even though the name sometimes suggests that. And as my message to you here today, I also want to leave you with some action items that you can take on from this and take forward. What can you do? Well, I think what you can do is to actively think about and consider passive house. When you're looking at real estate, be that a remodel, a retrofit, they have the EnerFit standard for that. New construction, if you're a politician, a stakeholder, a developer, a decision maker, if you're in real estate, think about the passive house standard. Consider it for renovations and new buildings in the realm that you're dealing with real estate. If you're a decision maker, if you're a politician, think about requiring passive house for public buildings, provide that leadership. Think about implementing it in private developments. There's plenty of developers now who have elected to make this their own yardstick. Why? Because the mid to long-term economics of passive house are very favorable. So if you're an owner, a developer who's holding real estate, this is going to be the cheaper route. So beyond the environmental comfort and other benefits that I shared with you, you can make some money off of this here as well. And if you're in a position to do so, consider getting passive house trained and or certified. So again, you can become a designer, you can become a consultant. There's a tradesperson program. If you sell or make products for buildings, there's certifications for some of these products as well. So these are all things that you can do and you can bring to your community to get the word out on passive house. So with that, I will leave you here with a couple of resources, and thank you for your time today. And I am happy to take your questions. Thank you very much.
Thank you so much, Tim. Your presentation was so informative. We just have one question here I'll get to in a second, but if it's okay with you, I will share your email in my follow-up email to our registrants. So if anyone has any additional questions, they can shoot you an email.
Perfect. That is fine by me. Please go ahead and do that. It's also on the screen right here in the lower left-hand corner. You can find us at tstudio.com.
Wonderful. So we have a question here from John. What was the construction cost per feet?
Yes, 1 second. I wanted to turn off the screen share here. Is that necessary at the moment, or do you want it on?
Up to you. You can turn it off.
Yeah, if I could find it. Okay, let's focus on the question first. So construction cost per square foot. Well, I could shoot you a number, but you know as well as I do, construction costs vary greatly depending on where you are in the country and what you're building. So I think that's a meaningless paradigm. What's probably more important is how does that stack up against other things that are being constructed in my area or were being constructed in my area at the same time. And so what I can tell you is, for a comparison, I do this for custom homes, but I also work in affordable housing. And so we see an investment cost in passive house anywhere from, I would say, nothing to about 15% of construction cost. And the spread has everything to do what your baseline is. So when I work for an affordable housing developer where they have to build everything as cheap and just bare bones code compliant, they may see 12 to 15% cost increase, but it's not really that, it's an investment. It's like solar panels because it pays you back. And they see an ROI on that of about 12 years. When we deal with custom homes in my area, in my region here, there is often no additional cost. Why? Because the custom home builders and owners, they overbuild, they don't build to code. They already build better mechanical systems, they build a better shell. So here we're just focusing the investment on certain areas, and there's often horse trading we can do within a project budget. So arguably in a custom home, it makes no difference. In the worst case example of an affordable housing project, again, measured against the absolute minimum baseline code allowable construction, you may see 10 to 15%. If you look at this more broadly, in markets where this is done more commonly, most people will tell you 3 to 5%. So, and then with an ROI, the years almost equate to that, of anywhere from, let's say, 2 to 6 years or something like that. And after that, of course, you're running cheaper. So that's also important. That's the whole thing with an ROI. That's when you break even on that investment. And from that day forward, it'll be cheaper to own the passive house, which they generally are and were designed to do. So this standard and its targets has 3 legs. So the lifestyle component, comfort, resilience, all of that. The energy target, of course, the sustainability piece, and then the fiscal component. So it was specifically designed to target a low life cycle cost sweet spot.
Awesome. And then a few more here from Debbie. Are the extension shades also insulated?
They're not. So that's really important to note. Neither are they hurricane shutters, which is a question that I sometimes get. So the window stands on its own. These high performance triple pane windows provide about an R value of 10, 11. So they're about as good as a fully insulated 2x4 wall on the R value side. Then of course they have the solar heat gain component. So there's no additional insulation offered up by virtue of these shutters. It's something that wouldn't be very practical, especially in our climate zone with snow and frost and other things. To have something, you know, more solid out there would be difficult. Although there is some examples of people doing passive house in Alaska, where they did come up with some movable elements that they can park in front of the windows that add additional insulation. I would say the place in the world where you want to do something like that is a place when you're near the Arctic Circle and you have times of the year where you don't have any daylight, right? Then it makes sense to come up with a system to bring more insulation back to the window because you'll have it permanently shut. It doesn't have to undulate. It doesn't have to open and close multiple times a day. And in those particular instances, I think there is some reason to look at it. In our climate zone, so in the lower 48, there's no particular value in something like that. And it would just add a level of complication that is not worth anything here.
And are most windows fixed, and therefore is there a window cost savings? If so, about how much?
So the question of a fixed window versus an operator is really one of occupant preference, let's put it that way. The passive house will be mechanically ventilated. Technically, it doesn't need any windows. However, that's not how we live. There'll be windows, there'll be doors, there'll be times of the year when you want it all open. So there is no, I think that there's sort of a flaw in that, and so I don't want to go too deep down that rabbit hole. You know, you open a window in a passive house, you bring in what's on the outside. It's the same as in any other building, so the ramifications are the same. So you could say, well, for cost efficiency, I'm going to advocate for more fixed windows because they're cheaper. I would say a fixed window, depending on size, obviously, but it can be as cheap as half the cost of an operating version at the same size. So if you're smart about it as a designer and strategic about it, you can save a bunch of money by again using fixed windows to your advantage. But really, there's a lifestyle component here as much as anything, and then there's egress, you know, emergency egress and other considerations at play, and also the passive house standard doesn't govern any of that. So I just want to be very clear with that. It's not like you have to make a box with a bunch of fixed windows. No. In a cold climate like Minnesota, where we have extremely dry and cold in the winter and wet and humid and hot in the summer, we don't open our windows very much here at all in any type of building. So that's why when you look at my house here, you can see I have a lot of fixed windows. I was very strategic about that just because I noticed in the 20 years prior where we lived in a conventional home that really nobody ever opened any windows at all. And so we really maxed that out for us. Yeah.
And on the foundation, did you consider the cold climate version with exterior insulation, extending out from the foundation 4-inch and therefore not having to go down to frost line? Thoughts on why you did not use?
Sure. So a floating foundation is difficult in Minnesota. It's not technically code compliant. You have to go an alternate path. And because our frost depth is so deep here, if we do a wing, you know, basically coming off the building sideways, we have to go a very long distance, which doesn't really work on urban lots. That's something that you could potentially do on a rural lot where you have lots of room around it. So I did actually look at that for this particular project. I couldn't find any engineer here who was willing to go along with it. As I said, it's not technically code compliant. You need an alternate pathway. So is it thinkable? Absolutely. Does it get done in places around the world? Yes. But it's not practical in Minnesota at this moment in time, mostly from a code and engineering perspective. Yep.
And another question here from John, how do the automated shades perform in blown snow and ice?
Yep, very well. They're more resilient than they may look, perhaps. They're about 3 inches or so a blade. They're a folded aluminum that's hemmed over, so they're actually quite girthy. Every time we install them on a building, we do put a wind sensor on that building as well. They can go up to about 55 miles an hour, and then they retract for safety. So when you have a significant weather event, generally, at some point as the weather is starting to turn, they will go up based on that safety mode. I have not observed, I've been in this house now 2.5 years, so this is the closest that I've been to them for an extended period of time. I've also had them in my office since 2014. I have not observed a weather condition in Minnesota that would like completely blow and then take them over. We see, we just don't see that, so for us in the winter, it's so cold that the snow doesn't stick. It's kind of dry snow, if that makes sense. And in the swing seasons, we just don't see that happening where we get these heavy storms or something like that. I've seen maybe a little bit of freezing rain, but because I have a weather station, and like I said, I put this with every project, there's also a sensor that looks at, okay, if it's raining and it's 30 degrees outside, that's also a moment to write them up. So generally they go up to when we have conditions that look like it might be an ice storm or something like that. But to be honest with you, I also have a couple of clients who've opted out of automation who don't have that. And we've been putting these into buildings here for 15 years, and I have not seen yet, knock on wood, any damage to any of those systems, automatically or manually controlled. So they're pretty resilient.
Great. And a question from Dave. He built my net zero house in 2016. The 850 was 0.42. Is it possible to get passive house certification after the house is complete? He noted he should add, he also has an e-gauge monitoring system, so he knows the heating and water, heating energy records.
So in principle, that would be possible. In reality, more than likely not, simply because you need a lot of planning documents and also documentation of the construction to go through that process. So there's a pre-certification based on design. Then you have, basically surveillance while it's being built. And so you have to show that it was built as designed. Now, I'm saying in principle, it could work because he may still have that. He may have the architectural drawings and all the specifications for every piece of insulation and window that was used. He could hire somebody perhaps to get an energy model done after the fact. So all of these things could be done. But in reality, there will probably be pieces of information that may not be obtainable after the fact. And that may be the Achilles heel of trying to do it after the fact. So it's really more meant as a design tool and an accompanying thing than it is to go in and do it after. And the other thing I will caution is it is a fairly aggressive standard, not the name passive. It's the targets are actually pretty high up there. And I've had a lot of people ask me, it's like, oh, look at my design and surely this must be a passive house, that must be a passive house. It's not good enough to meet individual parameters. The whole thing has to come together and work under this principle. And generally, I don't know where he is, but at least in our state, I have never seen anybody casually produce a passive house. It's just not something that would happen. Not to say that it couldn't. Again, I don't want to step on anybody's toes, but it's unlikely. And then the other thing is, you're doing it after the fact. So you're not investing in the design and the passive house design anymore. So now you're just spending money on somebody backtracking the whole thing. And how much money would that be worth it to you to get that plaque on the building? I doubt that you would find that attractive. So and the building is what it is at this point anyways. It's unless you're looking to modify it again, I would say just enjoy that you have a really good building that is airtight and uses very little energy and leave it at that.
And a question from Dan, how many of the materials did you assess for potential green certification?
So that's a great question. The standard itself doesn't govern any of that. So that's really left up to the practitioner to figure out what am I using here and what other certifications am I trying to get. So for my firm, I could say that, we've worked with different standards over the years, anything from Green Star, LEED, Minergy, which is a Swiss-based standard. I've done embodied energy calculations and stuff like that. So I have a essentially sort of a good and a bad list of materials and products that we use internally here at the firm. So I would like to think that everything has undergone scrutiny. But that's, again, more something that's left up to the practitioners. So there are people out there who build passive house fairly conventionally, without much regard to that. And I would say that's probably true for some of the affordable housing projects, simply because there aren't any resources for that specifically. So it's an individual choice. So on this project, just about everything that you saw has had scrutiny, but I can't say that there aren't like conventionally built passive houses where that wasn't a thought.
And Debbie mentions excellent, very thorough answers. So much appreciate your presentation.
Well, thank you.
What are your thoughts on the prescriptive values of the passive house path?
Sure. Yeah, that's a great question also. When we say prescriptive, we have to keep in mind that the modeling is still climate zone responsive. So while the targets are absolute, there is the climate in the mix. And so there is some dynamic in the whole thing. And generally, I would say it's a program that works reasonably well all over the world. However, there are conditions, and we're probably bordering that in Minnesota and southern Minnesota, where I am, where it can be very difficult to make it work. So cold climates, obviously you get into the Arctic Circle, I talked about it. You have 3 months out of the year where the sun doesn't shine. Making a passive solar building and meeting passive solar design criteria isn't going to work. So there are places in the world where they don't work. There's been a lot of conversation over the years, should these targets be changed because of it? To be honest with you, I don't believe so, because the bulk, if you look at where humanity lives on the planet, I don't know, 80–90% of humans live in places where this is fully applicable. So from that perspective, I think the way it stands, it's perfectly fine. The one little concession that the Passive House Institute made some years ago was they also started to provide an entry-level certification called Low Energy Home. And I find that one is very attractive for us cold climate dwellers. So when you are in a place where you have very short days or just extreme cold, that one is an easier stepping stone to reach. And I think that was a welcome addition to the program. And I don't see them doing anything else beyond that. Personally, like I said, I don't see the need for that. And I had actually a conversation with Wolfgang Feist, who's the founder of Passive House. He's a physicist by training, about that. And he said, again, if you're in a location where all your amenities face north, so you have to put windows on the wrong side of the house, you're in the urban core, you're completely shaded, you just can't get there. Well, use all the other markers and tick them off as you can. You'll get the comfort, the resiliency. You still get all the same benefits. Just let it fall into place. And I found that to be a worthwhile conversation. That's how I've been practicing. And some of our projects don't meet all the criteria, are not fully certified, and that's fine. It's fine. There's still fantastic buildings. We've used the modeling. We know exactly what they are, and we were able to make transparent choices and really, truly value engineer the buildings with the help of Passive House. So some perspective on that conversation.
Great. And we'll take this final question from David. Where would he go online to download the current Passive House specification? He couldn't find it on the Passive House website.
Yeah, right. And so one thing to note is in the United States only, there's also two different programs. There's one called FIAS, Passive Building, which is a homemade newer thing. And then there is the Passive House standard, which is a global program that's been around for 30 years. So it depends already which route you're looking at. So one of them is FIAS is the US homegrown thing. That's phius.org. I don't use that as much, so I couldn't tell you off the top of my head where they have their criteria buried on their website. For the global standard, it's passivehouse.com. And when you go to that website, there'll be a tab on there where you can see the certification criteria, and you can actually download them. They update that frequently as they revision the program. So you should be able, from the main page, to click on certification criteria for buildings and download a current PDF. And that will have all the subsections in there, the retrofitting, the low energy home, and then there's 3 versions of the normal standard, if you want to call it that, with varying amounts of renewable energy on board. And they're all spelled out in there.
Awesome. Thank you so much, Tim, for your fantastic presentation on Passive House. And thank you all for attending this month's webinar.